Hello everyone, Robert Saunders here again. And guess what? Today, we're going to talk through Apex Block native replication, how I did it, how we stitched it together, what are the use cases. Here we are right here, use cases and options. Well, I can have multi-region, two different Apex Block clusters deployed to two different regions. Let's say, and you'll see in my example, a region in the east and a region in the west. And then I'm going to stitch up native replication, which provides me ability to manage it. I can do crash consistent, I can do point in time, and it's all non-disruptive. You'll see I'll do snapshots, and then I can make snaps of snaps. Some of the use cases, DR testing, QA, auditing and analytics. It allows customers to also use maybe the dark site or the DR site for more than just that. They can actually do some work with it. That's a really nice way to go. And we're going to manage it with PowerFlex Manager, CLI, and even the REST APIs. So let's take a look here and see what we have put together for today. So first off, the ports required, 7611 and 11088, that's for the SDR, the Storage Data Replicator. If you know about PowerFlex and Apex Block, you realize we need to also have this part of the equation. Of course, the MDMs also need to talk to each other. Why is all this important? Because between the two regions, I need to make sure these ports are open so these two systems can talk to each other. I'll show that, how I did this in AWS with peering here in just a little bit. So the topology here, east, system 1, and west, system 2. East is my source, west is my target. And again, I have volumes and different storage pools. I have that replication consistency group there in green, where I can even take a snapshot of a volume, and that snap you're going to see here in the demo is going to land on the target, and then I can mount it and consume it. I can also take snaps of snaps. And of course, I can fail over from source to target. I can run in DR as my primary, and then I'll reverse it and I'll fail back. So worth noting too that I deployed all of this with both regions with Apex Navigator. If you're interested in how to do that, you can check some of the videos, also part of this channel. But why we're here today is native replication, and then you can see there either VPC or VNet peering, depending on which cloud you're in. That's how we get it done, to talk between these two environments, and it provides very high level of availability for sure. So we're managing all of this replication with PowerFlex Manager. You've deployed it, you've configured it, you have it all stood up. I have a few things on the screen here. There's some PowerShell, there's Disk Manager. But first and foremost, let's look at the VPCs. I told you I did peering between them. So let's take a look and let's unpack this. Just to understand real quick, 170, that 170 block is in the west, and the 168 block is in the east. So what am I looking at here? I see local for 168 and also for the 10.0, that's the storage network. But from a front-facing PowerFlex Manager perspective, 170 is in the west, 168 is in the east, and then I have them peered. That's what that PCX connection is. So I'm looking at this from the view of 168, that's why it's local. I'm going to be going back and forth between both of those, so just so everybody's aware of what we're looking at here. The East Region Apex Block cluster, there it is. I deployed this again with Apex Navigator. Let's jump over to the West, and we'll see very similar topology. Looks like I don't have the Ubuntu jump host in there. I was playing around on the east side with that, but you get the idea. I have 5 nodes, a balanced config. It's also worth noting that for even more resilience, I can deploy a multi-AZ and then use native replication for multi-region. That's resilience and resilience. There's many reasons to believe why that is also a topology. We have some clients also doing that. So again, 168 is the East region. You can see there in the URL, and of course in the top right there, 168, just remember that is the East region. We're gonna be going back and forth. The West region here, again, is 170, and I have a jump host over there also. Now, I actually am going to both PowerFlex managers from this same jump host here, 168 and 170. Why? Because I have the peering connection. I can also do that. So let's take a look at this replication consistency group here. See the blue box on the bottom? Replication test east 2. That's the source, and then the target is over on the west. So we'll look at the peered systems. Again, this is viewed from the east. The west is the peered system. So I'll drill into this here. Take a look at the replication consistency group. There it is. Again, source is local, 168 in the east. Target is west. So now, let's generate 1,100 random text files just to show a little bit of a load. So I got some very easy PowerShell here just to write out 1,100 random character generated text files, very small. Just want to show some work getting done here. So there's 1,100 of them. They're generated and they're being replicated across almost in real time. You see my lag is pretty low there. So everything's pretty much already transferred. So now this is pretty cool. I'm still on the east side. I'm going to take a snapshot of this replication consistency group volume. I'll take a snap of it. I'll give it a name. Now this is pretty interesting because this snap is actually going to happen on the target side, which is the west. I'm not going to snap it on the east and then push it down the pipe. It's just snapping it on the other side so I can then consume it. This is pretty cool. So back to the replication consistency group. Got some choices there. Create the snapshot. Again, the snapshot is taken on the DR side, which is the west region in this case. And then I can go over there and I can mount it and I can do some work with that data there. It'll be read-write. So there we go, the snapshot's created. Now to view this snapshot, I need to see it from the west view or from the PowerFlex manager that's attached to the cluster in the west. So I did flip over to the west PowerFlex manager. I log right back in. And now let's take a look at volumes here. And then I have 2 RCG snapshots that exist. I did a test one and then I did the second one here and recorded it. The latest one is the most recent. I'll expand there. So now I want to map a snapshot to this jump host, actually, where I also have the SDC client running on this jump host. If you're interested in the SDC client, I have some other videos on that. You understand how to do it. So this volume is only in the west. So again, my IP address 11.0.2.7, that's where my SDC is. And I'm taking that volume that's part of that snap, and you see now it's there in Disk Manager. So now I need to bring this volume online, and then I can browse it. There's all 1,100 files. But that's not the actual volume that's being replicated. That's actually a snap of that volume. So let's copy in, just copy paste some new files there. Let's write some data into one of the files just to show not only we're writing files, but we're actually editing the files in the snapshot copy. Again, QA, dev test, big data workloads, anything you need to do here, AI workloads, you can do all of this on that DR side if you'd like. Some other snapshot options. And then when I'm done, I can unmap it. And maybe there's another developer on another jump host that wants to use that snap for something else. Then that person can mount that jump host, or I'm sorry, mount that snapshot on his jump host. So now I'm going to do the demo of a failover from east to west. Our primary, again, is in the east. We're going to fail that over, so west is going to be our primary. Very easy to do here. And I'm managing this failover, again, from the view of the east cluster. I go into the RCG, I go to More Actions, and I click Failover. So I'm picking point in time to simulate kind of a DR, disaster recovery. So now we see the RCG status is stopped. That's perfectly fine. Now the next step we have to do is reverse it. What does reverse mean? That means the west now becomes the source and the east becomes the target. So I've simply moved my primary writes and workloads over to the west. So I click reverse and apply it. And now we'll see this switch. There we go. The source system is now the west and the target is the east. So we'll jump back over to the west. Apology for going back and forth between there. But now I see this volume here that I can bring online. So again, this one only has the original 1100 files that we wrote. That got replicated at the very beginning. Now I'm going to write 10 more files here. Now I'm literally just going to copy and paste 10 here total. So now on the west, I have 10 new files. I'm back over here on the east, and I see the volume is unallocated. That's exactly correct. That's what I wanted to see. Now, I want to do a point-in-time failover to get back to the steady state. I'm going to fail west back to east. And I expect to see all 10 of those files that I wrote on the west now appear back on the east. So I reverse that replication again, this time west to east. We see this change. The target system is the west. The source actually just shows the identifier there. It doesn't actually say east. So now the source is set back to the east, and the target is again our steady state, which is the target is the west. Now this is where it gets pretty interesting. The disk was actually online during this failover, so I wanted to show this. This is, I feel like it's a Windows exploring kind of presentation presenting the stale data, because if I take a look at this, the disk is online. I don't see those files. So what I need to do here is offline and then online the disk. Super easy to do. So when you fail back from that DR state, and I'll go back in and I will see those 10 copies, there they are, of the files. So I know everything is correct there from a failover and failback, replication, consistency group, Apex block. Thank you for watching. Appreciate it.